Okay, this is project 5, right? Part 2. What we're going to do is we're going to see the current state, whether we are in execute or fetch on that 7 segment. We'll be able to see the program counter, the current miner cycle, and the instruction that we're reading. So in the SRAM, I already loaded in address 1. I'm skipping address 0 because everything starts at 0. And then the first fetch, the second clock pulse of fetch moves us to address 1 on the program counter. So the first one is LDA, then I have a NOP, then bin, I forget what it stands for, and number 4 is another NOP. So I already loaded this data into the SRAM, and I'll show you how I did that. It takes a long time, so I'm not going to show it on video, but I have a direct write code which allows us to choose an address and a data, and then when I upload this I can just write that data into that address. And then I have also, for testing purposes, I had a read which can let us load an address and then display the SRAM data on LEDs. So I already did that. Now we have our actual code with all of our flags. So the first thing I'm going to do is we're starting at 0 here. So with the first click, we are in the fetch state, and we're on the first miner cycle. So as you can see, we have some flags going up. Oh, another thing to notice is our current instruction is still 0, hasn't incremented yet. And so currently we are in fetch and our miner cycle is 1. So if we look at fetch with the first miner cycle, we should have these 4 flags going up. So I already took all the necessary flags and I put them into a little chart here to make it quicker so you don't have to look at schematics. So for fetch we have PC to bus 1. Well, actually I'll go from the LEDs. So we have LED 17 on, and 17 is read, right? And read is right there. So this is for the first miner cycle. Then we have LED 15. LED 15 is PC to bus 1, which is right there. So we're still in fetch clock pulse 1. LED 12 is transfer to accumulator 1, and that's right there. And then the last one is 8, and 8 is bus 3 to memory address register. So the correct flags are being displayed for the fetch on the first miner cycle. So on the second miner cycle, we have a program counter increment right here caused by those flags. So what we'll see is the program counter will go to 1, and that's this 7 segment, the one to the left, right there. So now we have program counter 1, and because program counter is 1, we're also looking at an instruction inside the RAM, and the opcode for that instruction, LDA, is 1. So we're seeing the opcode right here in hex. So we've fetched, and then we have a few more sections to show for fetch. So we're on program counter 2, which is this section. We have LED 15, which is PC to bus 1, LED 9, which is bus 3 to PC, right there, LED 6, which is 1 to bus 2, that's where our increment comes from, and then LED 5, which is add, we're adding. So that is a correct flags for fetch on miner cycle 2. We'll go ahead and increase. Now we're on miner cycle 3, which is this bottom section. So we have LED 13 And LED 13 is MBR to bus 2, MBR to bus 2. LED 11. LED 11 is transfer 2, transfer 2, TRA 2. 7 is bus 3 to IR. So we have the correct flags for the third minor cycle of fetch. We go to the fourth, and there is no flag. This is a wait, so nothing's happening. So we'll go ahead and start executing. Since fetching is loading an instruction into the instruction register, we have to read the instruction. So the first step of executing anything is going to be read. So LED 17 is read, and as you can see for LDA, clock pulse 1, which is minor cycle 1, we're reading. So that's correct. There we go. There's nothing. There's a wait on clock pulse 2, so that we have nothing. And then minor cycle 3, we have LED 13. So if we look here, LED 13, MBR to bus 2. And we do have MBR to bus 2 for LDA on clock pulse 3. So LED 11, TRA 2, TRA 2. LED 10 is bus 3 to ACC, bus 3 to ACC. So these are the correct flags being displayed for clock pulse 3 on LDA execute. Next is 4, and there is a no operation and wait really on clock pulse 4, so there are no flags. Next we have a NOP. I'll go a little faster through the NOP. The fetching is exactly the same, and I already showed that those work. I skipped it by mistake, but whenever we went to minor cycle 2, we incremented the address. So the address is program counter 2, which means we're at address 2, and that's a no operation, which is opcode 0. So this is correct so far. And that button skipped a little bit, but since this is a no op, nothing happens during the execute. So we saw nothing happen on 1, 2, 3, still nothing's happening, and we go back to fetch. So the next one is bin. I forget what bin stands for. Branch if negative. Yeah, I think that's it. So we are on fetch PC2, and yeah, so our minor cycle needs to go to 2 in order for us to increase to PC3. So now the address is going to be address 3, which is bin with an opcode of 7. So this is correct. Our fetch worked. I can move ahead to our first execute step. We're reading just like before from the instruction register. And then 2. Okay, so we're executing bin. Bin, there is nothing that happens on clock pulse 2. Additionally, there's nothing that happens on clock pulse 3. So that's clock pulse 3. Oop, it skipped on me. But now we're on 4. That should not say no operation. We're supposed to have, okay, so these are the flags we have. We have LED 14, LED 14, MAR to bus 1, MAR to bus 1. LED 12, TRA1, TRA1. And LED 9, bus 3 to PC, bus 3 to PC. So we have the correct flags for bin. And then I ended everything with a no operation. So we will fetch, as you just saw, we went up and fetched, and we went up in program counter, so our address is at 4. So we have a opcode of no operation, which is 0. I think it's also called halt. And we will execute and nothing happens. And then beyond this point, it's just junk in the SRAM. So it works.